All right, thanks for having me. So today we'll talk about the results of a recent survey that we did focus on usage of generative AI in the healthcare sector. And by way of introduction and disclosure, I am an active advisor and investor in many companies in the data and AI space. And I also serve as a chair or co-chair of numerous conferences, past and present. And so, while I am not an expert per se in the healthcare domain, I'm quite steeped in data and AI and have a lot of hands-on experience with the technologies that we will be discussing. So this was an online survey that ran for about a month. Uh, Respondents were recruited via social media, newsletters, as well as online advertising. We had about just over 300 people complete the survey. Um, but bear in mind, this is a survey focused on usage of generative AI. So we wanted to focus our analysis on the people who were working at organizations who were actually actively using generative AI. So when all is said and done, we had about close to 200 people who fit that category. And that rest of this presentation will focus on those 200 people. Another thing that we did was we wanted to identify people who held leadership roles because we believe that they have a better sense of how their organizations are actually using and evaluating generative AI technologies. So we kind of uh, set aside three specific roles for people and bucketed them under the category technical leaders. And when all was said and done, there were about 55 people in the survey who fit this category. So during this presentation, I will particularly showcase the answers of the technical leaders. All right, so a little bit of about this presentation. Obviously, this is a presentation about our recent survey, which you can go directly read using the URL provided earlier. But I also wanted to bring in surveys and reports on generative AI, not necessarily focus on healthcare, because I believe that, I mean, this technology is changing fast. There are lessons to be learned from other domains as well. And so we might as well look at what people in enterprises are broadly doing about generative AI. And also, I have my friend here, David Talby, who's much more of a domain expert in healthcare. So he will also weigh in on during various stages of this presentation. So think of this presentation as more of like a data fusion, where what we want to do is provide you with some useful takeaways at the end. So let's begin with budget, right? So are people actually budgeting for generative AI? So this is a survey recently conducted by the venture capital firm Andreessen Horowitz. Say they talked to dozens of Fortune 500 companies, and within those companies, they identified just over 70 enterprise leaders, and they then proceeded to interview these leaders. And the focus of the interviews were how are you using, evaluating, and budgeting for generative AI? And as you can see, broadly speaking, in the Fortune 500, there's a lot of bullishness around this technology. Now, in our survey, if you look at the number of people who project that they will double from 2023 to 2024, at least among the technical leaders, that's about 34%. So 1 in 3 will be doubling their generative AI budget. So let me pause here for a minute and ask David. So David, does this kind of resonate with you in terms of what's your sense of the level of budgeting that people are doing for generative AI?
I would say this definitely drives to what we are seeing. I think if anything, it's even more than that. I think there's a
So
outright
it's more
crazy
like this.
level of foolishness. Yes. where if before people were really fairly conservative in money, maybe spending on things they really had to do, cybersecurity or kind of just operational aspects. There's a whole lot of money going towards really at this point a lot of experimentation with generative AI. A lot of really it's really like the beginning of the internet. People really assume that this is going to be a major thing. There's a lot of recruiting going on, a lot of just switching projects to this area, and we definitely see this within healthcare as well.
All right. So next area of focus will be what LLMs, what large language models are people using? So again, this is from the Andreessen Horowitz survey. As you can see, everyone they spoke to is using OpenAI. The most popular open source model is Llama. About 41% of the technical leaders that they spoke with said that they are using Llama, and about 2/3 are using Google. And I do want to give a shout out to Google Gemini 1.5 because I've been using it, and it's actually quite impressive. It's a simple API, it's fast, and it's multimodal model, and also it doesn't have as much friction as you might think you've encountered in the past, where in order to use this model, you might have to sign up for a Google Cloud account. No, now all you need is an API key. All right. So now, so this previous slide was showing that a lot of people are really at the moment skewing towards the proprietary models. But this same survey from Andreessen Horowitz, you can see the bullishness around open models, right? So 41% will increase or already use majority open models, and another 41% plan to switch to open models when they match performance. By the way, I prefer the term open models to open source because it's technically not really open source, right? Mm-hmm. So now, what about our survey, right? So our survey reveals a much more nuanced picture when it comes to healthcare. So healthcare specific models are much more preferred than just those general purpose models, proprietary or open, right? So, but when it comes to general models, our respondents preferred the open models over the proprietary models. So again, let me pause here and give David a chance to give us a heat check. Does this resonate with what he's hearing?
Yes, overall, yes. I think one of the big differences in healthcare is the privacy and compliance aspect, right? Where you're just not going to send patient data to any API, right? It's Google or OpenAI or Azure or whatever may be the case. So in many cases, it's just not an option. So what people do is, very often come and say, yes, I can start with Llama or Mistral, right, or one of the other open models and do it that way. The other thing that we are seeing a lot in healthcare is that the general purpose model are just not that good. And I think it seems to me, I mean, I'm most of my time is healthcare and life science, but it seems to be that compared to other industries, there's a much bigger gap between kind of general purpose model and what you really need in the healthcare space, even for really good models like GPT-4. So, and I can tell within our own benchmarking within Johnson Labs, I mean, you look at really small task specific models. Sometimes LLMs, sometimes like not even LLMs, right? Other generation models, you can get materially better accuracy. Right, so really going back to an LLM, sometimes it's easier, right, and it's prompt-based, and you can do it quickly. But sometimes you get 3, 4, 5, 6 times the number of errors, right, that you get with really just an off-the-shelf model.
So for David, for our healthcare audience, what would be the best way to use these proprietary LLMs? I guess very early on when you're kind of playing around, so you can probably use it as some sort of early proof of concept or whatever. But any concrete advice on how they would approach these proprietary models?
Look, one thing that people do is, yes, they use it basically to play around, right? So you use it with fake data, right? Because you cannot load actual patient education, actual patient data, actual clinical trial results. So using fake data basically to learn what's possible. But I think what a lot of people are doing when they're actually developing solutions, right? They would start with the model that they deploy behind their firewall, right? Under their control. And Johnson Labs provides some of those, but people go with open source, like with other ones. Because people deploy it on premise, they usually there are different considerations, right? So first of all, they want to measure accuracy for a task, right? I think something that's probably going to happen on the kind of wider LLM front as well is at some point someone goes, look, it's really cool that it's Gen AI, but like, is it actually better, right? Does it actually work, right? Then compared to what we had before, because look, at the beginning we see a lot of first projects where people use an LLM for for things that you can do with basic text classification, right? With super basic question answering, right? Where really LLM is a complete overkill. The other difference that we are seeing, and I think this is why there's a lot of people who kind of try to use the small task-specific models. When you deploy it on your own, cost of the hardware becomes an issue, right? So if you kind of say, oh, for example, look, I have a model. The model say, it reads incoming emails and it routes them to the right place, okay, automatically. And you can do it with some text classification, or you can do it with an LLM, right? And maybe there are advantages doing with LLM, prompting and all of that. But if I tell you, look, to do this model, you need to buy, an H100 machine, right? Which is, just the hardware is $300,000 a year. That's a showstopper right there, right? And I think that's another reason, right, why people go to the small models, right? Because really, a lot of the things you can do, honestly, you can do them on a CPU with 16 gigabytes of memory, right? Which is far more cost efficient and easier to manage.
All right. And so another shout out for the open models is as this most recent AI index report for Stanford shows, the ecosystem is incredibly vibrant. So expect them to continue to get better and keep pace with the proprietary models.
Mm-hmm.
All right. So let's look at use cases of LLMs specifically in the healthcare, pharmaceutical, and life sciences domain. So we recently put out a report on generative AI in healthcare, and one of the things we did was look at the S&P 500, look at all the companies that fit into the healthcare, life sciences, pharma space, and we looked at what they're saying about generative AI, and we found a lot are really exploring many interesting use cases in terms of the use of these technologies. And more recently, I actually looked at job postings in the US, online job postings in the US, uh, pertaining to generative AI. And then what I did was I pulled the job postings that mentioned healthcare specific use cases. And as you can see, companies are actually hiring talent, and they want that talent to solve very specific use cases in healthcare. And then the other thing another hopeful sign here is the AI index report from Stanford. This year, they have a whole chapter on healthcare and science. And I pointed out because basically this shows you that even researchers are focusing on applications in healthcare. I mean, so this is the only chapter that was domain specific in the report, as far as I can tell. And what does this mean? This means that expect maybe better models that are targeting the use cases in healthcare and life sciences that you care about. All right, so now let's look at what our survey says. All right, so I want to point out two specific areas, right? So one is, I would say, information extraction and knowledge management, right? So you can see examples here: information extraction, medical text summarization, transcribing medical encounters, clinical coding. The other kind of bucket I want to point out is chatbots and co-pilots, right? So you have medical chatbot answering patient questions, machine translation, right? So these seem to be the areas where people are focusing a lot of their initial efforts as far as generative AI in healthcare. Now, if you compare that to broader enterprise, right? So this is again from the Andreessen Horowitz survey. They have somewhat similar kind of conception, right? So a lot of people are focused on information extraction and knowledge management, and those tend to be more internal facing applications. And then the external facing applications, the co-pilots and chatbots, tend to be less popular. And here, I guess the conclusion that you can derive, and I'd like to get David's take on this, is that at least for internal use cases, people are much more maybe aggressive in terms of trying things out. And as far as external facing applications, they're very interested, but they're a lot more cautious. So,
Yep.
David, what's your take on at least the use cases that we surfaced here?
Yeah. So look, the challenge, for example, right, if you allow patients to log in and ask any questions, there are just more risks there, right? So first of all, people in general are going to ask you questions about, politics and why don't you believe me and why didn't you do this and I heard you got this lawsuit and all these kind of things. On top of it, if you make a mistake, right, if you have really one hallucination, one mistake, one misread thing, that can get you, in the newspaper and in the courts, right? On the other hand, especially in healthcare, there are whole professions, right, around being a clinical data abstractor, right, being a clinical coder, a contract review, pre-authorizations, right? Those are really, there are hundreds of thousands of people who do this stuff manually, right? And now really we are on a verge of real change there, right? Where, for example, if you matching patients to clinical trials, right? Now we have people who read the content, right? And for an average US cancer patient, there are more than 1,000 pages of text written about that patient every year, right? And so to summarize, for example, to get a patient into a registry, which is done once a year, it's, could be easily 2 to 3 hours, right, for a breast cancer patient, and it's done manually. And now you can automate a lot of these things. And because organizations already have these things in-house, right, then first of all, there's a very simple cash-on-cash ROI, right? If I can do this faster, if I can do this cheaper, it just pays for itself. The other thing, I can have the human review, right? So it's not like, it's not a binary thing, okay, throw it all to the machine and let's hope regulators don't come after us, right? You can have those processes, but okay, I can have a human review after, right, where I'm unsure, right? So, and I can have a workflow that comes and says, look, let's see what recommendations the algorithm gives me. Let's send them for human review, right? At some point, you turn off the human review when you see that human experts stop changing things, right? You come and says, look, they only change 2 out of 100, right, entries. Just don't ask them anymore about, stents, cancer staging, right, family history, and you can just make progress this way, right? So and look, and you have around BI, around regulatory submissions, around billing and coding, around fraud, waste, and abuse. You have really hundreds of those processes that traditionally are extremely kind of human intensive, manually intensive. Okay, and they're fairly at this point. I think people still kind of underestimate, how much of a change it's going to cause in the healthcare space.
All right. Now let's look towards the future and see how our respondents are thinking about the potential impact of generative AI. All right. So before we do that, let's look at the current impact, or I guess what we know so far. Right. So I wanted to call out this study because I think it's interesting. It's the first study at scale, right? So this is 5,100 customer service support agents at a Fortune 500 enterprise software company. This study was conducted by researchers at Stanford and MIT, right? So what did they find? Well, first of all, I want to put this in context, right? So here, custom LLMs in this study meant they did some fine tuning and focus mainly on fine tuning, but the system also uses retrieval augmented generation, right? So that's what they mean by a custom LLM. So what did they find? They found 14% increase in productivity. So give me a technology that increases productivity by 14%. I think a lot of CXOs will be excited, right? So the other lesson that they found is that this technology particularly impacts the people, the agents who were, let's say, below average, right? So it raised their productivity. So overall, it increased productivity by 14%. And the other thing about the study is this was fairly early on. So you can imagine the amount of tuning and further customization and learnings that they have been able to implement on this system, right? So not only does it increase productivity by double digits, but it also makes the low-skilled, less productive agents much more productive.
Yeah.
So
And
now
by the
let's
way,
look at. Oh, let me just finish here, David. So now let's look at what our survey found, right? So our respondents are particularly excited about the potential for chatbots uh, transcribing doctor-patient conversations, which means you will need probably a speech model and an LLM answering patient questions, so some form of copilot and synthetic data generation. All right. So over to you, David. I know you have opinions about synthetic data generation in
yes.
particular, but yeah. So the whole notion that this technology, at least the early evidence seems to be there's some utility here in this technology, right? So
Definitely, yes. So, look, first of all, one thing I also, I saw another study, although I'll see if I can find and put a link to the reference. It looked also at medical diagnosis and also shown really similar things that generative AI is especially good at helping junior doctors operate at the level of really very senior ones. And it looks like generative AI, it's a very unique technology because most technologies basically increase the gap, right, between the haves and the have-nots. And Gen AI, it looks like to be one of the technologies that actually does the opposite, right? And you can see it even, in coding, right? You can have really very junior coders that can do things, because you don't need to understand kind of, whole frameworks. You see it in writing, right? And that's one of the first things I saw within my own team, that you have people who now write, beautiful English, perfect grammar, very rich vocabulary, right? Even though they're not natively English speakers. And we do see this in medicine as well. And at least in medicine, kind of really that accuracy and lowering that skills gap, may be more important than productivity. And one thing I think that would be interesting one day is, we're probably, easily 20 years away, but one day it's going to become unethical not to use these tools, right? The same way that radiology used to be a luxury, right? And then at some point, it just kind of says, look, if you say the patient broke their hand, like, what do you mean you didn't do an X-ray, right? It's just not like, what, you just feel their hand. We just don't do that anymore. I think at some point we're going to get to this point with AI. Right? You can say, oh, what do you mean you actually built, a plan for a cardiology patient or a cancer patient without using one of those tools, right? You haven't read all the new research, have you? Right? And that we're going to get there. I think from what we are seeing with customers, there's a lot of interest, yes, in chatbots, because not patient-facing, even internally for clinicians, okay? Because everyone hates the EHR, okay, and nobody reads it because there's too much stuff there, right? So even as a doctor to know, look, really, has this patient ever been on an SSRI? Right? Today, if I just want to know whether a patient has ever been on a kind of medications, whether they've done this kind of test in the past 2 years, right? It can be within the EHR, it can be like 5 to 10 minutes just to click around and scroll down. And if I don't miss it, that's great, right? And just being able to summarize the patient over time, right? And usually it's not just the LLM, it's a combination, right? You do information extraction, right? Then you do some reasoning, then maybe you put in a knowledge graph from some other format, right? And then you translate natural language question to it. So there's a whole system, but we see a lot of interest there. Really to be able to ask about patients, group patients, and all of that. I think this year, next year, we're going to see many more large deployments of this. And that is going to be a game changer. On synthetic data generation, yes. I do have a strong opinion there. We offer it. We use it for testing. We use it for demos. My only issue with it is that I sometimes see it being used basically as replacement for getting real patient data, and that's where it doesn't work, right? So for me, because what I've seen, and we've done this several times, the problem if you ask Llama 2 or Cohere, right, or GPT-4 to generate say, a radiology report, a pathology report, right, with certain diagnosis. Basically, it does it well, but it's a bit too clean. Okay, so the problem is if you ask it to do 2,000 patients, 10,000 patients, it's going to be a bit too clean, a bit too normal, a bit too well done, which makes it a bit too easy for models to do things, right? So I've seen several papers where someone says, we generate synthetic data set, right? Because then we don't need to deal with human subjects and all of that. And for example, we want to predict, cancer staging, right, from pathology reports. And I can tell you that, if you can get to F1 score of like 0.98, right, with the synthetic data, it means that on real world data, you'll probably get to 0.83, right? Because there's much more noise, much more really wrong data, conflicting data, missing data, bad vocabulary, bad grammar, right? Things that are just not there in real world data, much weirder cases, right? And sometimes, and really the thing in healthcare, sometimes you see real patient stories where, if GPT-4 would give him to you, you kind of say, oh, like this is impossible, this is totally hallucinated, right? But in healthcare, everything happens in the real world. So I would say, for me, synthetic data, yeah, it's useful, really, for demos, for testing. I would advise against it if you actually want to look at clinical outcomes.
So, David, what's to the best of your knowledge, what's the status of synthetic data from a regulatory perspective? In other words, if you use synthetic data to train your healthcare specific model, you would have to disclose that to the regulators, I would imagine, right?
Yeah, definitely, yes. Look, and you cannot, like synthetic data kind of doesn't count if you want to have a medical device, right? Like, look, if you do a clinical trial, you do it on actual people, right? On actual patients, right? You can't do a clinical trial on made up people.
Right.
Yes.
Right.
So look, so of course you can use synthetic data to train a model, and you can have your model, but you need to test it on real patients, right?
But I would imagine even if you're not doing it as a replacement, even as a supplement, you would have to disclose it, right?
Yes. Yeah, you should definitely disclose it. Yes. But look, but more importantly, if you make any claims about how effective that model is, right, I would say that you cannot make that claim on synthetic data.
All right. So the next section is how do we decide which LLM to use, right? So generally, in practice, right? So this is what happens, at least for me and most of the people I know, right? So a new model gets released, you read the release notes, you look at how it does on certain benchmarks you care about, but you know that benchmarks are always subject to optimization, right? So, but at the end of the day, there's really no getting around the fact that you have to try these out for yourself, right? So on your data, on your use case. Machine learning and AI are very, very much empirical disciplines. So there's no getting around the fact that you will have to try it for yourself, right? And as far as our survey, right? So what do people care about when they evaluate the specific LLMs? Well, first, security and privacy, as David pointed out. So here I'm calling out what the technical leaders are prioritizing, right? So the fact that the model that they're dealing with is healthcare specific, very important. Legal and reputation risks, which includes hallucination, and of course accuracy, right? So it has to have some level of minimum level of accuracy. So David, any comments?
Yeah, I think, look, I mean, definitely drives to what I'm saying. Look, the thing that people benchmark against the most is accuracy, right? Because, if you say you can, automatically summarize, clinical trials, the immediate question, okay, like how well do you do it, right? And how can you prove that? I think the other things are kind of really just entry tickets, right? So for example, if there is any issue on security and privacy risk, like we will not even talk to you, right? So there's no situation we will send the data externally, right? Either because I just know I can't do it, right? As a healthcare system, right? Or as a pharma company, or look, if you ask me to do it, you ask me to spend the year with my compliance team, and look, I'm just not, It's a quality of life impact, that the customer is not willing to take. Similarly, healthcare specific models. Very often people tell you, look, if your models are not healthcare specific, people can say, look, just don't, right? It's just not an interesting conversation, because really people have had so much experience within those organizations with trying general purpose models, right, and seeing really the accuracy gap and the fact that it's very hard to actually to close it. And of course, same thing about legal and reputation risk, right? So, like for us, for example, we build a whole system where it's designed so that it does not hallucinate, right? It comes with a set of healthcare specific guardrails, right, on top of all the standard ones. We have tests specifically, right, for bias, but also those are the kind of things that organizations don't expect to build this in-house, right? So like I don't expect to need to fine tune my model, right, so it does not return swear words, right? Or answers with racial slurs. But if you not show me that you've done it, right, then like in a sense, why even do a POC, right? Yeah.
All right. So now let's turn to roadblocks, right? So what are showstoppers? So I actually, in the report that we released, we looked at several survey papers that dedicated to this topic, and we created a mind map, which I'm displaying here, so which you can also read in the report, right? So what are the things that people find challenging as far as healthcare AI? So as far as our survey, so what are some of the key things that people really feel like are roadblocks, right? So as David said, accuracy is number one, right? So secondly, reputation and legal risks, and then bias and fairness. But again, another thing that keeps popping up is it's not built for healthcare and life sciences, right? So, um, all right. So, what about enhancing and testing models, right? So, once you have a model that you've picked, how do you make it better? Right. As far as testing, what are people testing for, right? So, obviously, privacy, private data leakage is important. Hallucinations, also quite important. Bias and explainability. I mean, I don't think there's anything healthcare specific here. These are all, most enterprises uh, will focus on these areas, right? And so, as far as customization, so this is from the Andreessen Horowitz survey. It turns out the 70 plus enterprise leaders in the Fortune 500 that they spoke to, many are already down the road of fine tuning. As far as pure RAG, only using RAG, much less, right? So, but fine tuning seems to be something that people are already actively engaging in. So, in our survey, what we found is people are doing human in the loop, right? So, meaning, get feedback from a human, improve the model, right? So, supervised fine tuning. So, the key word here is supervised, which means you need to come up with labeled uh, prompt response pairs in order to fine tune your model. So, which means you need the help of domain experts. The other thing I wanted to highlight here is reinforcement learning from human feedback. It's a much more advanced topic, but also requires domain expertise, right? So, in fact, all three of these things I highlighted requires that you have domain experts, which means that whatever tools you select should be something that domain experts can participate in. So, in other words, don't rely on tools that only coders can use. At some point, really getting the most out of the models will require, especially in healthcare, your ability to make sure that your domain experts are actively participating. And in fact, I wrote a post which compared supervised fine tuning to reinforcement learning from human feedback. And essentially, supervised fine tuning is assuming you can come up with the fine tuning data set, which is the pairs of prompts and outputs. It's mainly a solved problem, I believe. Reinforcement learning from human feedback might be more powerful, but it's also much more complicated, and there's no really accessible tools. So once tools become accessible, then maybe that technique becomes more popular. But for now, I think supervised fine tuning has become basically very developer friendly. So again, to emphasize, what you really need to focus on is to make sure you work with tools and vendors where domain experts are part of the mix. So David, I'll stop here and see if you have some brief comments.
Yep. Look, first of all, I mean, I completely agree. I think, look, if you look at the things here, human in the loop, supervised fine tuning is the two most common things. It matches with the fact that in healthcare, not in healthcare, I think in larger enterprises in general, it's more risk averse, right? So even if you have a baseline model, you can say, look, I'm not just, it's not like email marketing. Oh, let's see how it does, right? It's look, no, I need to know how well it does. I need to measure it. Otherwise, I might be just doing illegal things, right? And this is really another thing. Like, bias is a good example, right? If you're biased against, if you're not doing as well, your model is not doing as well for black people as for white people, this is just outright illegal, right? And you are not allowed to put something in production before you've tested it, right? So it's I think that it's a higher bar than other industries. Other than that, yes, I completely agree that you need to have no-code tools, right? For example, we've recently announced the Generative AI Lab, which is the 6th major version of a tool that enables you to do just that. So it enables you to start with prompt, play with them, test them, fine-tune them, have feedback loop, have human in the loop. You can load examples, right? You can have either kind of training and tuning sets, or you can have blind validation sets, and you can have a human work to validate it. We see it used, I would say, in almost every project, not just for validation, also really for human in the loop to provide feedback. One thing that you see a lot in healthcare is that really you do need medical doctors in every project, because what happens is often is just developers or data scientists will just miss things, right? So you can see if you have an example and you have say you have a male patient who is pregnant, then okay, anyone can say, oh, this is impossible. But I've seen many examples where you can see, oh, this is a cardiology thing, and a doctor would look at it and just laugh out loud. Oh, it's impossible that you gave this medication to a patient with these lab results and they didn't die. And I look at it, it's like, I don't know. All I see are 15-letter words of different drug names, right, and test names, right? And there are a lot of things within healthcare that you really need to be a specialist, right, to understand if something makes clinical sense, if something is the right decision, right? And we have a lot of projects that deal with, if you see this genomic variant, right, you may want to send it to this test, right, but you may not to do this other thing. And at the end, the problem is really, as a developer, as a data scientist, it's like really, you can look at it, you will not see anything wrong with it, right? And having domain experts very early on as part of the project and on every day within the project is just absolutely critical.
All right. So let's close with a few brief takeaways. So we've covered a lot in this presentation, but let me give you my top 4 takeaways, right? So first is that in healthcare, you need healthcare specific models. I think there's no getting around that. We've seen that throughout the survey, right? So they prefer that at the model level. They prefer that as when they're even evaluating models and looking at models, and so on. And then the second thing is, in order to get to the models you actually want, you need to have human in the loop tools, or tools that are friendly to non-developers, right? So in other words, as David said, particularly in healthcare, generative AI is really a team sport. So you need all hands on deck, particularly the domain experts, right? So many of them won't know how to do anything in Python or anything like that, right? So you need to have tools that are super friendly to non-developers. Third, there's a significant increase in generative AI budget. So, of course, there's always the possibility that you get left behind. So there's the FOMO, fear of missing out. So you don't want to do that. But as David said, there's also increasingly a need on your side just from patient care, right? So this technology can actually improve healthcare delivery results. So you'd be remiss not to kick the tires and try them out, right? So otherwise, you might be left in a situation where you're much more inefficient and you might be more error prone than your competitors, right? And finally, open LLMs, uh, they are continuing to get better. Um, so now I think it's fair to say that on a general purpose level, the most famous proprietary models, right? So I'm talking GPT 4 or 5, Gemini 1.5 or 2, Claude 3, and beyond, right? So they will probably always outperform the best open models on general purpose tasks. But the open models are keeping pace. So it's not like they're sitting on the sidelines. They're always also releasing better models, and these models have friendly licenses and they are amenable to fine tuning as long as you have what I mentioned here. You have tools that will allow you to fine tune it with the participation of your domain experts. And with that, I want to encourage you to try generative AI if you haven't yet. It's still getting started. We're probably, if this were a marathon, a 26-mile race, we're in the first half mile. So we have a ways to go in terms of extracting benefits here. So it's better to get started early. So a couple of things do want to emphasize. Generative AI is still AI and machine learning, which means you still have to have all your useful ducks in the row. In other words, you have to have data, right? So think about the two hello world examples in generative AI, fine tuning and retrieval augmented generation. Both assume you have data and you have the pipelines to maintain your data quality. Uh, and it's still machine learning, so you still need to have all your tools for monitoring, DevOps, all of those things. So nothing changes, right? So don't believe the hype. You still have to have your fundamentals in place, but it's really promising in terms of the use cases and the potential that it can bring. And with that, thank you. I have a newsletter and a podcast. And I don't know, David, do you have any closing thoughts?
No, I think what you said is spot on. I think we are very, very early on, very exciting times, a lot of innovation in the healthcare front, right? And it's it's always been impressive, really, last 10 years to see how fast open source closes the gap, right, to the best closed source models. I think it's especially valuable within healthcare because in general, you want to use models that you can run behind your firewall, under your control, fine tune them yourself. And I think you can do, you can do much more than you could do last year or even last month. And really, the main thing to know is, it's going to, it's going to keep getting better at the same pace. And other than that, we are seeing. We have now, several customers already in production with systems, and you can. It's a bit like the beginning of the internet or beginning of the cloud, where you can see the results of these initial projects, and those moments. It's like, oh my god, that everybody is going to be doing this, right, 5 years from now, right? And healthcare is slow. It's probably going to take 20 or 30 years, but yeah, it's going to be a lot of fun. There's a lot to do.
Yeah, and one topic we actually didn't really touch on is the fact that most of our we this is a generative AI survey, but truthfully, we focus on text. But there's generative AI in other modalities, and those models are also getting better. Audio, speech, right? So images, video, and so we're increasingly going into the multimodal world. So if I would say last year in 2023, the word of the year was copilot, right? So this year, I think the words of the year are multimodal and agents, right? So
Mhm.
the ability to handle more data of different types and the ability to build things that are much more autonomous. And with that, thank you very much.